Hey everyone, welcome back to the to episode number 25 of our live coding a Raspberry Pi Pico emulator from scratch. This is the final episode. I must say it's been a crazy ride, starting from writing the very first lines of the emulator in the first episode and trying to get it to sort of run the blink program from somewhere in the middle just to close the loop initially. And then I think we spent around 10 episodes trying to implement all the instruction set until we got back to the same point where we could run blink, but that time it was from the beginning to the end. And then so many more episodes on getting USB, PIO, and whatnot. I don't even remember. We did all this crazy stuff with GDBdiff, and Valerio was really helpful, and Graham, and all the other people here in the chat. So today, what I want to do is sort of wrap up. There is still a lot of work to do, and let me share my screen. So if we just take a quick look at the datasheet, first of all, let's just get rid of all these USB tabs. Last time we implemented all these USB and dived into all those USB descriptors, but now it's working, so we don't need it anymore. Yeah, all the USB stuff go away. No need to dig into descriptors. And if we take a look, so I think we implemented the most interesting peripheral, the most unique peripheral of the Pi Pico. That's the PIO, and we spent, I think, 3 episodes and a few spontaneous live streams just getting it to work, and now it's mostly usable. There are like some, I think there is even an open issue, some things we still need to do, like the FIFA joining. I don't know if we will get to that today, but it's definitely something that I will do at some point. And then we did USB, we started doing UART, and there is a bunch of other stuff we haven't looked into, but I have a feeling it will be very similar to USB and UART. There is I2C, SPI, PWM. We also did a timer, sort of. There is the watchdog timer, the RDC, and the ADC. And I think the SSI lets you write to the flash chip. So that's another thing that we probably need to do if you want to let the program write to the flash and not only read from the flash. But I think all the remaining peripherals each have their own like special thing, but I think the most interesting or the most complex ones were the PIO and USB, and we already did them. I didn't find any point in doing all the other ones on a live stream. Hey Nekati, good to see you here, and also Valerio, good to see you here every time. And I think we got into an amazing point where the emulator can run, and I think you have seen this. It's already integrated on Wokwi, and well, my Chrome is slowish. I don't know why it's so slow. Anyway, there is like a bunch of cool examples that use this Pi Pico with many different kind of hardware and with PIO and whatever, and it just works. There is like I don't know if there is a link here with, oh, there is the MicroPython guide. So there is even like support for MicroPython, and it's all built on top of the RP2040JS library. So I think it's pretty amazing. So I think today what we are going to focus on is first of all, a bit of refactoring. There are like a few points that we sort of wrote in a hackish way, and then we never got to sort them out. So that would be one of the focus for points for today. And then the other thing I would love to. So if you check the other simulator that I have, AVR AJS, it comes with a sort of with many examples where you can just like Christmas LEDs. You can just open this example and just very similar to work with. That's StackBlitz. It's a service that let you run front-end code right in the browser without setting up a development environment. And this is one of the examples of the AVR simulator. Oh, that's a very old version, 0.9. It's already, I think, it's 15 or 16. 0.16, so yeah, that's an old example. But the thing is, if you just want to integrate the AVR simulator into your code, you have this like bunch of very simple examples that you can copy from. And let's run this one. Just blink some Christmas lights, and I think it will be very useful if we had the same thing for the Pi Pico, for the RP2040. If anyone wants to use this library, right now all you have is this example. Like we have this two emulator run and the MicroPython run examples, which are useful, but they show you how to use it in Node.js, not in the browser. And then I also think right now you can't even import it into StackBlitz. So if we go to StackBlitz and let's start a new project. Oh, they do have Node.js support. Let's just do TypeScript, like blank TypeScript project. So if we import a library here and try to use it, if I'm not mistaken, we'll get an error because it requires it does work, but I think as soon as we try to import it, let's import. If it works, I will be surprised. From RP2040JS. What's up with my... Maybe it's not my Chrome that is slow. Maybe it's my keyboard. Yeah, I don't know. Yeah, so yeah, it sort of worked, but I think as soon as I will try to use this console log hello, just to use this value. Yeah, so it says it can't find this package, and if we look in the console, we'll probably, or maybe not, maybe in the real console, it will probably tell us why not, or maybe not, just telling us it can't find this package. Anyway, I already know why, because I had this problem when I tried to integrate this library with Walkwi. So when we export this all those things from the package, we also export GDB TCP server, and this file imports stuff from net. So we don't have net on the client side. It's a Node.js module, and for that reason it doesn't really work, because this is like front end. This package doesn't exist here. So we'll try to fix that and then create a few examples of using this library. So the next time somebody opens the README, they will have like this example section and not have to figure out how to set everything from scratch. And at least with AVR HJS, people did really cool things with it. I think there is like a list here, maybe, yeah, like people, there is this one, which is by Understone. It's been updated not too long ago, so it's like an Electron app with the Arduino simulator built in, really cool, with a bunch of different hardware modules. And then there is this one which I really like. It's like a virtual robotics lab where you can just write a bunch of code and see the results. So it's sort of interactive lesson based on the AVR simulation library. So here just turn the LED on, and you have like this exercise. And I think they even have something with robotics, so you have to move this robot, and there are like a few different environments, and it has like this sensor for, I think it's an ultrasonic sensor, and you have like to write a code that will use the sensor and collect all the coins. So this is like just I don't think I updated this list recently, so these are just like a few examples of what people did when we gave them the power of AVR simulation in the browser. Imagine what people will do when they will have this thing, RP2040, in the browser. So that's what we are going to try to do today. So first of all, let's start with this refactoring, because it really I have problems sleeping at night knowing that this code like exists on GitHub. So it's good that these are the things I'm worried about, but still, let's fix this. So yeah, you can see like I think this is something we did at the very beginning. All of this like code, if we check it, 5 months ago, like the very beginning of the project, where we were still working on the instructions, and we implemented all of those things in a hackish way. You see the SSI peripheral, some bits of the SSI, and then some bits of the clocks peripheral, which we know that's like the simulation clock. There is a clocks peripheral, and this is the Vitor. So so I want to get rid of all of this like hackish, SysTick and everything implementation, to move it away from the constructor, and try to use, at least for some of them, to use this peripherals array. So I think the first thing we want to do is to start with maybe these clocks, because it's super simple, and we already have like there are like 2 registers that we need to return one for this, or at least that's what we did last time. So clock space return 1. So let's try to do that and see what happens. So clocks.ts, and then it's sort of dummy peripheral, export RP clocks. We don't need all of that stuff, and we don't need a bank, I guess. Maybe we do need it if we have some money we want to deposit in these clocks. Yeah, okay. And then finally, let's integrate this into the RP2040. So we just have to implement reading from those 2 addresses. So let's copy this. So switch offset, and yeah, we don't need a clock space. It will be we just need the offset. I mean, we get the offset, so we don't need to worry about the base address. And clocks is selected, and also return 1. Very simple dummy peripheral. Let's copy those constants as well, and then we won't need all of this these constants here. So yeah, just a little refactoring to make the code nicer, I guess. Otherwise, return super, and here we don't even support any write, so we can just return this as well. And finally, let's wire it into the simulation. So instead of returning an unimplemented peripheral, we'll just return this. And of course, we want to see if if it still runs. So npm run. That was prepare start. Yeah, and then we have start MicroPython for the MicroPython, and yeah, it says ABLO UART, so I think it works. And then let's see if MicroPython still works after this clocks change. I mean, it should probably it shouldn't probably change anything. Yeah, sleeps for 1 second, perfect. And we can create our first commit. We just moved code from one place to other, so shouldn't really change. Refactor clocks, move up clocks peripheral to separate file. Okay, separate, is that how we write it? I hope so. Not sure. Yeah, I think that's the correct one. Maybe not. Yeah. And let's commit this and push. And did I forgot to? Oh, I think I forgot to save this before I run the tests. So funny. Yeah. Oh, it was just I didn't. I organized the import, so it sorted the import. So it's not really important. We can, or maybe we can. No, it just sorts them alphabetically. I don't even remember the keyboard shortcut. Alt-Shift-O. I just hit it without noticing. So yeah, we can probably refactor. It's not even a refactor. It's a style change. 2040. Organize imports. Yeah, just to have them sorted. Anyway, yeah, so that's one step into a cleaner constructor. And now let's see. We still have a bunch of other peripherals and stuff going on here. There is like this SSI, and I'm not sure if we already have like anything for this SSI. I think it's like, yeah, this address. So yeah, read the hooks. Yeah, and then there is like this Victor and Vic and this Cystic, and I think they are all like under this PPP base. So maybe that could be like, yeah, we could probably create not sure what is PPP, but I think at least we can move all of those into one file, but maybe I don't know if it makes more sense to move all of those to different files or just one file. We'll look at it, take a look at the doc. Anyway, it seems like Cystic got pretty much stuff, like it got a bunch of stuff going inside. And then also like this NVAC, and then there is like this is also the NVAC, and I think the vector table is part of the NVAC, so all of this is part like, and this is part of the NVAC, even though the comment starts here. So basically this is all NVAC, and then we also have all of this SSI stuff. So let's take a quick look at the SSI peripheral to see what the datasheet says about it. SSI. So this controls the QSPI pin and used to communicate with external flash devices. And yeah. So IP modifications. Interesting. Yeah, I never cease to discover new hidden corners in the datasheet with more information and more behaviors. It seems like if we wanted to implement everything, that would probably never end. But the good news is that even without implementing everything, we still like get a very useful simulator. So these are all the SSI registers, and we have TXFLR, RXFLR. So yeah, they're like FIFOs. We are already familiar with them from other peripherals. So yeah, let's start by moving this stuff into its own SSI peripheral. SSI.ts, and we'll organize it in a moment, but first of all, let's copy all those constants away from the main file. They don't belong here. SSI, where are you? There you go. And then let's copy them here. And I'm not sure if this, like, it's under peripheral, so I guess it works similar in a similar way to the other peripherals, even though it has a strange unrelated start address. But I don't see anything special, so let's make it a standard peripheral as well. RP SSI. I think at the time when we wrote this code, we didn't even have like this peripheral abstraction. Okay, and then we have read and write, and we have this dr0, which is going to be an instance variable, and then read uint32 offset number switch offset case, and then we can do all of this. So return 0. I don't think we need this offset at the end of every register. Then there is like case rxflr, also return 0. So both FIFOs are always empty. And finally, there is like case SR is probably the status register, and in this case we return this combination of bits telling it that's probably receive FIFO not empty, transmit FIFO empty, and transmit FIFO not full, just to make the, I guess, the startup code happy about whatever. And then there is also this, which case, if we are writing there, we expect to read some value, dr0, and then return super read uint32, otherwise just return the default, and write uint32 with offset and value, and then switch offset. And here we only have one case, which is this case, this thing, then do this break. And let's move this constant out of the way. When reading the status, then tell it, okay, we did read it, everything is good. So yeah, there wasn't anything else, right? Yeah, seems good to me. And yeah, now if we run the code, we haven't wired this SSI. You see, we don't use this base, so I think at this point, if we try to run something, it will just be broken, or yeah, it will probably wait forever to initialize this SSI. But now we are going to, yeah, you see, it's not going anywhere. Even for the simple example, it will probably just yeah, you see it's reading from this memory address endlessly. It's not implemented. We didn't get that in the MicroPython because we disabled those warnings here in the console log level, but if we had them enabled, it would probably print a bunch of those as well. Busy loop that checks the value of the SSI. So now we also need to wire it back. So let's do that. So RP2040 peripherals, and this address RPSSI with these and SSI. And now if we did all correctly, it should just work like we did before. Otherwise, yeah, hello UART. It's happily saying hello UART, and also MicroPython should run correctly. Yeah, time sleep 5. Don't know why 5. Anyway, we don't need this one, and probably not this one as well because we don't use it. And we can refactor SSI. I need to know how we write separate. Yeah, I think I spelled it correctly. Yep, cool. move to a separate file, move peripheral to a separate file. So yeah, second refactoring, getting this constructor a bit smaller. Let's just double check. So we added this import, removed all those constants, and added the peripheral here, removed all those strange hooks here, and yeah, it's not really related, but we also moved the nvic comment here. Yeah, I guess we can keep it for now. It will go away in the next commit probably as well. So yeah, so now we got rid of all the standard, I would say, peripherals here, and we still got two. Are the tests running? Did we mess up with the tests? I haven't run them, so let's just check that. Don't know why this test runner isn't running. Yeah, but everything still passes. Let's restart the test runner, so we'll have the indication here and we won't have to worry about it. Wow, we have almost 300 tests that we wrote manually one by one. That's pretty impressive. I'm impressed. 85% coverage. Okay, and now what else do we need to do? Yeah, we have this NVAC and CStick, and we need to decide if they are going into a single file or each one to its own file. And I think one of the challenges here, or the things we need to consider, it's not really a peripheral. It's like, let's see what the datasheet calls this. It's sort of, it's part of the ARM core, so it's like built into the silicon of the actual ARM core. So if we take a look at the address map, it's called internal registers of the Cortex M0 Plus, and then there is like PPB base. So yeah, so they talk here about the features, interfaces, configuration, and then we have here, oh, MPU. We still haven't looked into that. I guess nobody is using that. At least I haven't encountered anyone who uses that. MPU is like a memory protection unit. But yeah, we have this VTOR and these like IRQs. And then there is like features, NVAC features. Single cycle IO port, SAO, wait for event, wait for interrupt. Yeah, we should also, I guess, implement wait for event and wait for interrupt. I think we mentioned those a few times in the past, but we really never really implemented them. So yeah, so you see, NVIC is like sort of a unit. So this is the instruction set. We already know that part. And then there is like exception, system control. So all of those system control register, that's how they call it in the datasheet, like system control. This is like all these vector related registers, like interrupt priority and yeah, VTOR and all of those registers, CStick, and then NVIC has its own section, but for some reason, yeah, so it got its own registers here. And then there is the MPU, which is also built in, but we haven't implemented that yet. So yeah, but like all those registers sort of live in the same space. So even though they are like a bit, you can see, or maybe not. I mean, there is some sort of separation in the addresses, but yeah, I don't think it's very prominent. So yeah, I think we'll just I don't know how to call it yet, but I think we'll just move all of this code, at least for now, into a single file that will deal with that. I don't know, where does the name PPB come from? PPB, does it say anything about what PPB means? Not really. Private peripheral bus. Okay, that's interesting. Now at least know what it means. Internal processor resources. So yeah, so private peripheral bus. Yeah. So now I at least know what this means. So yeah, I guess we'll just use this name PPB, and it's not a peripheral per se, but I guess we can probably use the peripheral class to implement this. I mean, I don't see anything wrong with that. It started E00, E00, like everything here starts in yeah, so everything here starts with this prefix. If we go back to the datasheet, another USB go away. Yeah, we have been there somewhere, and we have seen that list somewhere. Yeah, everything starts with like all the offsets are always E0 something, so we can just use that as the offset of the PPB sort of peripheral. It's not really a peripheral, but I think we can put it here and try to treat it like other peripherals. PPB stands for private peripheral bus. These are peripherals that are part of the ARM Cortex core. And one thing special about this sort of peripherals is that as far as I can tell, they are unique per core. So there are two sets of them, and we'll have to take care of that, or maybe I will have, I don't know. I'll probably continue with doing live streams at some point. I'm not sure whether it will be this project, another project. So if you have any requests, do let me know, or suggestions. But at some point, I will probably implement multi-core for like dual core for this emulator. And then we'll have to worry about all these per core peripherals and all of this stuff. So, but for now, we can probably, and there is one copy for each processor core. Yeah, but for now, we'll just have this comment and then export class rppbb extends base peripheral, implements peripheral. And then we can copy all of this. Maybe we can also, yeah, let's turn it into a doc block comment, a proper one. So now if you hover over this rppbb, it shows this documentation, included peripherals, NVIC, and SysTick timer. And then we can probably move all of this specific stuff into, yeah, all of this stuff into this. And the constructor is so much shorter and sweeter now. And read uint32 offset number super.readUint return offset, and then here write uint32 offset number, then return, or not return, just super write uint32 offset number, offset and value, sorry, and This reminds me, why isn't this one happy? Huh? Why is it failing? Oh, yeah. I guess the tests are failing because we just removed a bunch of code from, yeah, that makes sense, from the NVIC. So it's good now that we have tests, we'll be able to see if everything works well when we put those back. Anyway, so yeah, so what I wanted to check is we had this SSI peripheral. Oh, we didn't call super.write uint32. That's too bad. So let's edit. So here we return, otherwise, or maybe default super write uint32 offset and value, just to make sure there is like we get warnings if we write to an unimplemented address. Okay, and now let's try to convert all this junk into this hook stuff into proper read and write. So let's have yeah, Vitor equals 0, and then switch offset case Vitor, return this dot Vitor, and the same here, switch offset. So the fallback will be this, but then case Vitor, this dot Vitor equals value, return. And we are done with Mr. Vitor. We still need the offset though. RP2040. Yeah, all of those offsets. Some of them are also actually, who is using that? Oh, we are using that inside this. Yeah, maybe we can export them from here and then import them. Export const Vitor is at this one. Yeah, maybe we'll have like I don't know yet. Anyway, all of those, we don't need them here. They are only used here in this PPB thing. And we can also remove this E because we know everything starts with E, so this can be part of the like peripheral address. Okay, so yeah. And then we have Vitor here, and then we have all this NVIC stuff. So all these right hooks go here. So case and this just gets value, return. And maybe we can just RP2040 equals this, because this needs to touch all these like interrupt stuff of the RP2040. It equals value, it doesn't equal break. Okay, and then we have like case this, then yeah, do this, and here it's value, and you can probably move this const here. Where is this max hardware IRQ? Where do we use it else? Yeah. Yeah, I guess it will be part of this file, and then we'll just import it here. Or maybe we can have, yeah, I think it makes more sense to have like IRQs and then export IRQ, and then like have all those constants in this IRQ instead of having them scattered. I think right now they are like scattered in different files, so yeah. So it will be an enum and we can probably export const. So that's RTC IRQ max hardware equals RTC IRQ dot. Yeah, and now we can just sort of later on refactor, or maybe we can do it now. No, we'll finish with this and then we can move the other like IRQs that are scattered across the peripherals into this file. No, I don't want to delete the entire file, just like those IRQ numbers here. And then here we can just IRQ dot. And what else do we have? This is just IRQ.uart1. You don't need to repeat the word IRQ here. IRQ.uart. This is one that was 0. So yeah. IO bank 0 RTC. Okay. And then what else? So this one will be imported from, I hope, the right place, the IRQ file. And here we can also like, this is just IRQ, IO bank 0 IRQ. Yeah, I think we are done with this and this. And now we can enable the interrupt. Oh yeah, we had to fix that one. So yeah, now we fix it, and yeah, we have this case ISCR, and again just updating a few variables and break, and finally we have this case this. Then enable the interrupts, break, value. Yeah, tech debt is not always so much fun to pay, but it's fun to see the result. And then let's remove all those offsets. We don't need those prefixes. They're just making things a bit more cumbersome. Made sense to have this like prefix when we had everything mixed up into a single file, but now we can have the privilege of just calling them without this offset. And then there is all like these reads, so let's add them here. Yeah, case, so much fun deleting code. Return, yeah, return RP2040, then they are happy as well. And we have this yeah, this strange thing that we'll need to worry about. But first of all, let's do those few SHBR2 and SHBR3. Yeah, so case those. So turn RP2040 and the writes for them. So case without the offset, and then RP2040 and return, and also here return should be consistent. It should always be return or break, but it should be consistent. And let's copy those constants from the main file. Yeah, so So we had those here. There we go. So we already have this one. And export const, and without this e prefix. Yeah, so now we still have this this horror here. So yeah, so given it sort of generates those indices in a loop. So what is that? It's just like an array of registers. So basically we can do something like that. We can have IPR0, that's probably the first one, right? Yeah, IPR0 to IPR7. Yeah. Const NVAC IPR insert. Yep. Almost perfect. And now we can just add those to another switch case. And this can be NVAC. And this is also like all the NVAC start together. And then we can put another big switch case that will do this. So all this. So case NVAC IPR0 to 7. Then just do this thing. And then we can say something like case. And it's too bad, like in C++ you can do, I think, something like this instead of like just give it a range instead of like listing all these options individually. But that's JavaScript, that's not C++. So we have like const reg index, which is just offset minus the first one divided by 4 or shifted by 2. And here we just up 2040 and it's happy. It doesn't complain, at least. Then we can do something similar for writing. So yeah, we have this, and then we have all of those cases together. And finally, we can have this. Yeah, we should also like keep this reg index because we use it, and here it's like RP2040 and just value instead of new value. And finally return. Okay, and we have it on the same line. No, it's not happy about it, but here it is happy about it. I wonder the mysteries of. No, I don't know why. Oh, I get it. Yeah, because the return was outside the block. That's why Prettier thought it would be nicer to format that way. Cool. So we have this part figured out as well. And now we only need to worry about this cystic thing. So yeah, let's do all the read hooks first. So cystic goes here. Cystic. And then case this. Sort of. Then we have and again RP2040 without a return here. And finally here we just return those two spatial constants. RP2040 now we have this for cystic, and finally, what is that? Oh, just, yeah, we can probably even refactor it even better. Oh, so write cystic this way. Let's keep it consistent. Cystic. Okay, and now let's paste this thing and turn those into cases. Case this, then do this. Don't forget the return. And finally, here another return. And yeah, now we need to move everything to RP2040. And yeah, this should, why don't we have a logger here? I mean, I think we, oh, it needs a return. That's why it's not happy. I think it's logger is part of this peripheral, isn't it? Oh, it uses it. I got it. There is like this helper method which we should use instead. Okay, so at this point we sort of refactor it, and now all the stuff is in a different file, and it still doesn't, the tests still don't pass, and we still have a few broken usages here because we still haven't migrated the code, like we still haven't integrated this peripheral. And yeah, there is like those reads from yeah, I think what we can probably do is, you know, instead of like storing those values of, where do we store those SHBR? Yeah, do we read them in the RP2040 class? I think it might make sense to, I mean, why do we read it from here instead of just, you know, reading? Yeah, I don't know. It's funny, we store them here, but then we read it using read unit 32. So yeah, really strange. So I would either store them here and read them directly instead of using read 30 unit 32, and then yeah, I think that might be the easier way. Or otherwise, I would just store them inside this class, like we do. I mean, it makes sense to do the same. So either store everything here. I think I will move it there. Yeah, I think that makes a bit more sense to me, even though I'm still not sure it's the best solution. But then we don't need to read them using this. We can just read them directly. We don't need to read them with this read function. And then this.shbr2 and shbr3. And yeah, and now what else? Yeah, again, this.shbr3. Okay, so this one is happy and this one isn't, because now we need to read and write from the RP2040. And yeah, I'm not sure, like maybe if we spend a few more minutes, we'll be able to remove all of those, maybe the cystic. Do we even use them? No, I think we don't even use them here. So yeah, we can probably move all the cystic stuff at least here into this class. So this RP2040 doesn't have to be concerned about this, right? We don't really use anything spatial with only like the exception number. Who uses that? Yeah, and then there is like this pending sysdig, but it's like a different section. It's just like for the interrupt itself, for the exception itself. So then, yeah, we can probably do this dot whatever. Yeah, instead of having those scattered across two classes. So now there is like one central place, and then RB2040 here that controls like this, that has the state of sysdig, and yeah, nice separation of concerns, I would say. And RB2040.clock. Yeah. Yeah, and we still have a few to-dos. It's not a great implementation of sysdig. Anyway, so yeah, now I think this is all green, which is fine, which is great, not just fine. And what else do we have here? So here we have, there are no errors, but there are failing tests because we still haven't wired this sysdig. So let's do it. E00E, new RPPPB, private peripheral bus TPPB. And maybe now it will all be green, maybe, let's hope so. No, it's still failing. Let's try to figure out why. We don't need this PPB base anymore. And yeah, let's see why it fails. So let's try to focus on this one and see what's going on there. So PPB, do we get into the PPB code? I think no, it's actually, it's strange. It's not green, but it's not gray either. Like, it doesn't even get here. E000E, and here it's E000E. So why don't we get here? Maybe we have some if or something like that that makes skips. Let's see, right uint 32. What happens here? So yeah, interesting. It doesn't even get here, even though here, oh, that calls read uint 32. Read uint 32. Yep. Yeah, we can see it doesn't find the peripheral. Interesting. Even though let's print the address. I expect this to be like E00E404 414, yeah. And then what's this? This should be E00E, I guess, unless I missed something. Oh, interesting. Yeah, there is this thing with the atomic rights, and I guess it clears the 2 more bits, so it's taking only yeah, it clears these bits here, so we get E00C. Yeah, and this peripheral is like sort of spatial, so maybe we can do something if address and return, or maybe we can even yeah, we can probably do it like that, this dot ppb, and then just, you know, store this in a spatial place. It's not going to be like the standard peripherals. It's private. I think we already do it for some of the peripherals, like the UART. Yeah. Read only PPB. Okay, and now it's running. Will it be green? Maybe. No, not yet. So find peripheral. Oh yeah, we should compare it to this one. But yeah, we can see, or maybe we can just say address shifted by that was we wanted to remove 12 bits. Yeah, so it returns the PPB, and now we do go into the PPB, or don't we? Do we get into? Yeah, we get into redo in 32, and yeah, it might get a wrong offset though, because we are. Let's print the offset. Offset. Yeah, I guess we get here this too, because it's probably calculating the offset again using those relative to yeah, relative to this address, not this one. Yeah, let's see where we call find peripheral. So yeah, we are doing this thing, the offset. Actually, it should work, I guess. At least with write, does this atomic write, but with read, yeah, oh, that's right again. Where is the redo in 32? Yeah, we just yeah, I think we could solve it like that. I'm not sure if it's not going to break anything, even though all the tests are now passing, or most of the tests are passing. Which one are failing? Remove from filter. Yeah, these are still NVAC bits, so not sure if I'm happy about this. I think this should be like the correct way to go. If we are reading from atomic write addresses, then it should probably just return the values without this atomic write property. Let's see if there is anything in the datasheet about reading from those addresses. That was inside here, or maybe, yeah, atomic register. So this is right. Do they say anything about SA does not support atomic access? Yeah, they don't say anything about what happens when we read from those addresses. Right. But I guess they should be the same as reading normally. Okay, let's hope this isn't bad, this change, and let's see why it still fails on this register. So let's focus on this test and see what we did wrong here. So yeah, we can see it go here, and it reads, yeah, we are writing to ICPR. Yeah, I suspect that this is like, this has to do with those, yeah, it's, instead of writing, it's calling atomic set again because of this like strange, maybe we should just override this, or I don't know, it's not a peripheral per se. Maybe we should just make our life simpler and just not try to treat it as if it was a peripheral, at least from the API 2040 side. So instead of like find peripheral, we can just, you know, do something in read in 32. Just add another case. And it's nice to have everything covered. Else if address dot read in 32 with address. Yeah. So yeah. So now reading should be implemented, but we still need to do the writing. And then we don't have to worry about this atomic stuff. And yeah, so here. Just do something similar to what we did with read. This.ppb.write uint. Yeah, we also had like this spatial case for the SAO and then value, so it makes sense to have ppb here as well. It's not like the standard peripherals with those atomic rights, and now everything is green. Perfect. So I think we could probably call this refactoring successful, even though I'm thinking now the list of constants suddenly became more manageable, and also the constructor is finally just, where is it? Here you go. It's just 2 lines long instead of like this long scroll. This file is still too big. It's like more than 1500 lines of code. That's a lot, but at least now it's a bit shorter. Let's remove this from filler. And, you know, as a last sanity check, let's just check that the code still runs like an actual program. Yeah, hello UART. And let's also try with MicroPython. Print, hooray! So yeah, it seems like nobody was hurt during this refactor. And now, before we sign off this, I also want to see if it makes sense to move some more variables into this, not SSI, into this PPB section, because we have most of the cystic state here. The question is whether we can move other values here. I guess we could probably move those SHPRs. And yeah, Vitor as well. I wasn't sure about them. I'm still not sure what's the best place for them, but since we already moved like the cystic stuff, I guess we can also move them. Have less clutter here, because they are more or less controlled by this file, even though the other one reads them. So this, and then here also this, and then here as well this and this. And let's go back here, and instead of reading them from this, now we are going to read them from this.ppb, this.ppb, and this.ppb. ppb and ppb. Yeah, and we can probably even sort of divide it further into, and we may do this when we get to implementing multi-core, like sort of 2 parts. One part will be the main microprocessor with all those instructions that we have here, And then the other part will be all this exception and interrupt control logic, which is what we have now split across here, like all these NVIC registers, and then all these like exception, set interrupt, check for interrupt, exception priority, all of these like exception return, exception entry. But yeah, I think it might be a bit complicated to split that. So for now, we'll just keep it as is. Lots of code. And yeah, I think we can probably keep those. I mean, where do we read them? Yeah, we can probably keep those. It's a good question whether we should keep those, all those like pending SV call, pending CStick, if we should keep those here, or like, where do we set the Nmi Mask? Ooh, we don't even use this. Just have this. No, we do use it in syscfg uses this. Okay, good to know, but I don't think we are doing anything with this. Probably nobody needs this. Yeah, I guess it's. What does this do? I want to know. Nmi Mask. Yeah, okay, so what does it mean that it's an NMI? Probably it means that CFG, there is like an NMI interrupt, I guess. NMI. The IRQ signals are masked, Nmi mask, and then OR together, creating the NMI. What is the course NMI? There is like a spatial exception for, I think it's a spatial exception like the NMI, like we have this CStick, and maybe it's here. CStick. Yeah, these are like the interrupts, but not the exceptions. Maybe in the programmers module. Let's see, there is like this pandas v as well, so maybe it will be. What are all those bits? Where are they? ICSR. Yeah, there is a bunch of things we, I guess, haven't implemented. So there is like CCR. Yeah, maybe we should take a look at the ARM architecture reference manual. We haven't seen this one in a while, and maybe it will be more informative about this NMI. Yeah, highest exception priority other than reset, permanently enabled. Yes, so apparently we are missing this. We have like this interrupt Nmi Mask, but we never implemented it and nobody cared about it. That's interesting. So there is this register, and I don't know if it's ever used. Let's see if anyone writes there Nmi Mask, but we never implemented this NMI. Nobody cares. Let's just run this demo for now and see if it writes there anything. And then I wonder, why did we implement it if nobody is writing there? Yeah, I didn't see any There are a lot of unimplemented writes to the SSI now that we have it, but I don't see anything talking about the NMI. Yep, you know, NMI for you today. So yeah, I guess it's not really used. Anyway, I sort of digressed. Yeah, we should probably do it at some point at this NMI. But yeah, I think we should probably keep all this interrupt stuff. Maybe even move those ones back to, you know, have all the interrupt related things in one place, not just scattered, because the interrupt priorities are here and all the pending interrupts. So yeah, I guess these and these are related, so they should be together. So sorry for not being able to decide. It's probably doesn't really matter. Just yeah, just everything is so interconnected in the CPU core. It's hard to draw the line where you want to separate things. So yeah, just rp2040.vitor, and then I don't know, maybe in a few weeks I will revert this decision and move all those variables back to live as a part of the PPB. Yeah, but for now I think we can just, you know, quickly take a look at what we did and commit. So yeah, I think this is like the most satisfying part, seeing all of those of this code we removed from here, especially like these big chunks with the read and write hooks. And maybe we can even get rid of those read and write hooks altogether, and, you know, just not use them. If anybody wants to implement read and write hooks, they can probably just, you know, extend rp2040, like extend this class and override read uint32 and write uint32, you know, with yeah, it will just save those lookups. So let's just make sure that we don't use them anywhere else. And yeah, it seems like we don't use them anymore, so we can just get rid of them. And if anyone relies on them, they can just, you know, extend this class and then override read uint32 or write uint32 to do whatever custom processing they like. We don't have to provide this functionality here. And then into write uint32, let's just again make sure we aren't using these write hooks anywhere. No, just here. So yeah, we don't need this. And then read hooks and write hooks go away. Less code, more fun. And yeah, let's review this as well. All tests are still passing, that's great. So we remove this, we removed all those constants, move them to the RQ class. Read hooks, write hooks, goodbye UART, we use the new RQ enum. And then there is like those C-stick stuff that went to the PPB, and all this bunch of strange read and write hooks went to PPB. And yeah, here I think we can keep this change. It seems like it might be the better behavior than, you know, using these weird addresses. No, you know what, I don't know which is correct, but this works, so it works, don't touch it. And then we added here like this spatial handling for this PPB base address. Yeah, and yeah, I'm wondering if there is like better way to write this. It's other than a bunch of if and else's, but for now it sort of works and we are happy with it. So let's keep it this way for now. We got rid of those read hooks, and then again similar change in write, and got rid of the write hooks, and these are like just reading the values of those registers directly instead of using readuint32, complicating things. Here again the IRQ, and that's all. And I mean, with PPB we added so much code. Let's just make sure we haven't left any console logs or stuff like that. And with the SSI we just added this default, and yeah, refactor PPB move sysdig nvic to own file. Also get rid of the read write hook mechanism. And before we commit, just for the last time, let's see if everything works. MicroPython works. And then we had just start to see if this basic hello UART works. It works. Let's hope that everything else also works. Otherwise, I will probably have to work fixing stuff tomorrow and commit this. And finally, before we, I think, we should have probably specified the forgot to add a issue number, but anyway, let's let's just usually avoid doing it, but we just, I mean, it's so fresh, there shouldn't be. Let's just undo this commit. This issue number, yeah, and this closes 75. And yeah, I don't like to use the force, but I mean, we have just committed a moment ago, so I guess it won't be too bad. I guess nobody pulled the repo in that very like 1 minute between when we committed and now we can see it's closed properly. Yeah, so take that paid. One more thing I wanted to do, we created this IRQ class, so let's use it all around the place. I don't remember, I guess if we search for set interrupt, we can see like here we have this first IRQ, and there is like this one USB controller IRQ, which is 5. So let's just move this to the IRQ file. Where was that IRQ? So USB controller equals 5, and then we can just say IRQ.usbctrl and import it. And what is that? This.irq, that's for the UART. And what is I? So this.alarms. Oh, interesting. It just uses the hard-coded I think the first few interrupts are for the alarm, so it just uses the number of the index of the alarm as the index of the interrupt. Yeah, we can probably refactor this as well. So there was like interrupts. Yeah, you can see those. Yeah, they already have like this. They do have this IRQ in their name, but I guess we can just remove this. Timer 0 equals 0, timer 1 equals 1, timer 2 equals 2, timer 3 equals 3, and then just here, instead of using just I, we can do const timer interrupts and IRQ timer 0, timer 1, 2, 3, then just use set interrupt, timer interrupts indexed by I, which is the same, but I think this code is a bit easier to reason about. Cool. So we can also add like PWM rep, like all those missing IRQs, just you know, for the sake of completion. And we have USB CTRL and XAP, and then PAO0, IRQ0, PAO0, IRQ1, right? 2 IRQs per PAO, and same for PAO1. I mean, yeah, we could probably be explicit about the numbers now. If we are not going to have any gaps, we can just, you know, let the so DMA also has 2 IRQ0. So we can just you know, not specify the numbers, and it will number them sequentially. But since we already started, we can keep the numbers. It doesn't harm. And then we have this IO bank 0 and IOQ SPI and proc 0, SAO proc 0, SAO proc 1, processor 1, and clocks 17, SPI 018, SPI 119, then UART, ADC FIFO, right? 22, I2C F0 23, and I2C 1 24. And voila, we got all these interrupt numbers. Let's go to the PAO. I think we yeah, so where does first IRQ come from? It's in the constructor, so RP2040 PIO, and then this is like IRQ.PIO0 and PIO1 IRQ0. And I think we are pretty much done with this mini refactoring of using this, moving everything to the IRQ, to use this IRQ enum instead of having them scattered around. So all interrupt numbers defined in a single place. Not a lot of changes, but still I like this for the USB and for the timer. And then for PAO as well. Yeah, I think these are all like the peripherals that we have, and generate IRQs. Oh, there is like this IO bank, but I think we already have this, right? Yeah, it's already like part of the RP2040 update IO interrupt. So yeah, it works. So again, let's just the tests are passing. Let's just see that MicroPython still runs. Yep, and the standard and 2040 move IRQ numbers to enum. Okay, it works. And another small refactoring, improving the code quality, or so I think. Cool. So yeah, I think we have about 1 hour until the end of the stream and the end of this series, and there is like still like a lot of small things I would probably improve in this code, and I will probably why do we have this? It's from last time. We don't need this anymore. So yeah, so there is like a bunch of things I would probably improve here, and that probably deserve some more attention. And I'll probably keep working on this code over the next few weeks. If there are like any specific things that you would like to see, let me know, and I will try to record them or maybe do them in a spontaneous live coding sessions. But other than that, it works. That's, I think, the most important part of this big bunch of code works. And like as always, it can be improved in so many ways. But I'm pretty happy now after we removed all these hacky read-write hooks mechanisms. And I think now it's a good time to try to see how we can make it work on StackBlitz, and that's, or on any kind of web environment, and that's a bit different kind of challenge. We already sort of tackled that when we first published the library. That was the initial commit. Yeah, that was probably 4 months ago when we set up the npm for release and set up all of these all of these entry points and exports. And I think one thing we can probably do is export, try to separate this GDB code, or we can also try to there are a few ways to go about this issue with the GDB. I think that's the only issue we have right now, that's the GDB server. I would love to have GDB server as part of like this RP2040. After all, it's pretty tightly connected, tightly coupled with this RP2040 implementation, and it's pretty useful. But then if we use this, then we can't really use it on the web, these imports for net. And if we remove it, you will see we only use it like in very few places, like just when creating the socket and handling the connection. But most of the logic here in this process GDB message isn't like tied to a specific implementation, just like this handle connection thing that takes the socket. So I think there are a few ways we could go about it, and maybe one way which will be interesting, an interesting solution is to create a GDB server which will be generic, and then a GDB TCP server will just implement the TCP interface. So this GDB server will be reusable even if you don't have this TCP server, and then only export the TCP server inside Node.js. So let's try to do that. So I guess we can have this GDB server, which will be the more generic kind of case, and then have GDB. Yeah, maybe we'll change the name of the file as well to be GDB desk server. Just don't think we have many of those, but to stay consistent with this convention of using dash to separate words in file names, and then GDB TCP server will just have this specific code that uses that uses this socket. So export class GDB TCP server, and then we can have all of those like specific things. So this one, the generic one, only takes RP2040. It doesn't care about the port. And then this one, constructor RP2040, and it calls super with the RP2040, and this extends GDB server. And yeah, we should create this method, create server. What does create server do? I think it's somewhere. Where is that? Oh, it's from this is coming from net. Yeah, there are a bunch of those from net. Yeah. So yeah, and then here we don't really have a handle connection, so we'll refactor this to yeah, I guess what is, yeah, there is process GDB message, and we can probably have like so here we can probably have like process input, and that like, yeah, I guess, yeah, let's move this handle connection here and sort of break it down. Oh, we do have it here. So we need a socket here and socket set no delay. Yeah, I remember this one. It's, yeah, socket from net, not from dgram. Socket. I remember this delay that was making GDB so slow until we found there is like a method that disables Nagel's algorithm or so, that yeah, makes yeah, so yeah, and that made GDB's like connection so slow. Anyway, so once we are connected, I want to sort of separate this. So this on GDB data, and here we can just set up this log name, export it. Then here we can just, or maybe we will better just, you know, move those, create those methods. We can just copy it from the base peripheral, all those like logger methods, just, you know, instead of repeating this logic everywhere. So here just will be gist dot, what is this logger anyway? It's probably copying, oh, it has its own logger. Interesting. So yeah, just here we can call, it doesn't use the RP2040 logger, it has its own set of logger implementation. Not sure if that's the right way to go, but we already did it that way. And then instead of calling here this.logger everywhere, we can just call this.debug. So this.logger, this.info, this.logger. Yeah, this dot. Then we don't need this log name everywhere. Yeah, and then we can move this logic here to on GDB input data uint array. We'll just tell my phone to shut down, to shut up. Yeah, and here we can probably yeah, if we wanted to support multiple connections, then it would probably make sense to have like yeah, maybe another class TCP connection that will hold the state for a specific connection. Export class GDB connection, and then constructor private GDB server, and then it will like do all this logic of buffering that we had like implicitly stored in this handle connection. So it will sort of be the adapter that talks to the GDB server and implement all these like buffering and stuff. So we can move this here. So then we have on GDB or on incoming data private or not private, just data uint8 array, and move this logic here and have this buffer instead of as a variable, just buff as a private variable. And then yeah, what is this GDB message? And then we can remove this, the GDB server, this as well. This private RP2040, RP2040, this.server.rp2040, and then it can be read-only, doesn't have to be private. Read-only, yes. And then server.info, this.rp2040, and then instead of like private on response, and then it will just does GDB message return? I think it returns a string, right? Yeah. GDB response, or just export type GDB connect response handler that gets value string and returns nothing. And then we have this on response, and then here we can just call this dot on response with the response. Where is this coming from? Probably from here, right? Let's export them so they can be here. This dot server dot info break. Yep. This dot buff, or yeah, we can probably this dot buff instead of buff dot. This dot buff. And here we just yeah, data is, yeah, how do we convert it into a string? That depends. That's annoying. So if it's like in the browser, we can't actually use this way of converting it into a string. We'll worry about that in a moment. Yeah, and then here we are just instead of using this, we are just going to call on response. You can probably have this const on response as a local variable, just to not have to use this everywhere. Maybe here, so we can also use it here. And this.server.debug, this.server.debug, and this.server.process GDB message. And other than that, we are probably almost done refactoring this. And here, when we have a new connection, we can just const GDB connection, new GDB connection, this, and on response we'll just write it to the socket, write data, and then whenever we have don't need this nor this, think we deleted too much. Now we lost some of the, but we can find it here. We lost some of the event handlers that we had. So we have socket on data, and yeah, we also need to write this plus at the beginning. That could be something that, yeah, I guess here we should do it here. So inside a GDB connection, when we construct it, we immediately call on response. That's the first thing we do. We send it a plus. We are good. You are connected. All is well. Let's talk. And then here we can just add those event handlers. So, yep. So if we have data, then just these dots no, connection, just connection dot on incoming data. Maybe instead of incoming data, let's call it feed data. And then here it's just saying we had an error, and this error, and on close, I guess this .info GDB disconnected, or maybe yeah, we can probably keep it as console logs for now. It's pretty useful to see when GDB is connected and yeah, I mean, we have the logger for that. So this.logger.info, or just this.info GDB connected without a new line there, and GDB disconnected. And if we want to print them, then we know how to enable logging. That's why we have the logger, what we have the logger for. I mean, in the browser, we probably don't want, actually this is the TCP server, so it's not going to run in the browser, but anyways, yeah, so we are done with this, but we still have this issue where yeah, where we have this thing where we need to convert it to a proper string. So I think instead of we'll change the API, we'll slightly change the API, and it will be the responsibility of the user to convert it into a string, I guess. So let's see what happens if we have a break inside a string in Node.js. I think it will just convert it to this character. So like, let's create new buffer with this break character to string UDF8. Yeah, and then let's try it in the browser as well, just to make sure it doesn't break when we new int8 array, and it has this value, and then new text decoder, just converting it into a string the browser way. Yeah, it's just Unicode code point number 3. So I think we can just work with the string here. So to string UDF8, and then here feed data will just get a string, and we don't have to worry about it anymore. So if that dot charcode at 0 equals 3, then it's a breakpoint. Otherwise we just append this to buff. And one final thing we need to do now is why does it have a warning here? Yeah, unused import. We don't know, no longer need it probably. One final thing we probably need here is just to change this emulator run. Yeah, so we are no longer going to export GDB TCP server, just GDB server, which should be browser friendly. Also GDB connection from GDB connection. Maybe we can move all this stuff into a GDB directory as well. There are like a few of those. There are like all of those, like GDB utils. They are inside utils. So yeah, maybe we'll just move everything into GDB. Now that we have a bunch of GDB related code, and then it didn't update the imports for us for some reason, so we'll fix that. But then we can also move all these GDB utils into this GDB directory, GDB utils. Yeah, a few of them. And then we need to update the import. So this goes from here, GDB utils, and this is imported from here. Cool. And it's not happy because I don't know. Oh, that's a comma, not a dot. Yeah. And GDB server, and GDB connection, and GDB connection. Yeah. And this one should import it from the right place. Now everything is green again. And what's up with the test? I mean, we shouldn't have affected the tests, but I don't know. And then in emulator run, GDB server, and another one in MicroPython run. Yeah, just import GDB TCP server from whatever it is. And yeah, let's see if it still works and if we can still connect with GDB. It should be possible. GDB, oh yeah, GDB multi-arc. Yeah, we don't really care about this L file. Just want to see that it connects. Yeah, it's connected. Next. Can't find the bounds of the var. Yeah, single instruction, and it seems like it's running instruction by instruction. Continue, whatever, doesn't really matter. So it seems like GDB is still working despite all the changes. Let's try that one more time with the MicroPython, because I think we do have the debugging symbols for MicroPython at hand. So let's see if it makes sense. It should still make sense. MicroPython, yeah, there are like, I think we are running which version are we running here? Oh, we are running the release version, so we don't have the debugging symbols for that, unfortunately. Anyway, so let's just connect and see that it's happily running. And if we break now, it doesn't break. Interesting. I think we have seen this in the past where break didn't break. Let's try to see if we can fix that as well. So yeah, that's in GDB connection, and then it does spit break message here, but let's also console log break. Yeah, and restart it and see if we get it to actually break when we connect. Should, but so yeah, it doesn't. Interesting. So I wonder if this is like because we did something wrong here. Let's const log feed data, because the data goes to GDB, but it probably doesn't recognize the break for some reason. So maybe we did something wrong here. Let's see. Connecting. Yeah, and we can see a bunch of stuff. Yeah, I think as soon as we connect, we should also break, and we didn't do it. But yeah, we can see like the data is being fed, feed data, feed data, feed data. And let's see if we continue and break. Oh, it does break. We got a heart. That's the character, the glyph for character number 3. The glyph, however you pronounce that word. Anyway, so yeah, so break works apparently, but I guess we should break when GDB connects. That should be a thing. Did we do that before? GDB server. Oh, I wanted to see. We do. Does seem like break worked. Like we did get a, or now we don't get break. Didn't say. Oh, we did say break. So how comes we are still inside the REPL if we hold break? Probably something is broken, re-breaking. Let's see. So we are saying break, and then we are calling rp2040.stop, and then it says stop, and it says if this.execute timer is not null. Yeah, I guess there is something wrong with this mechanism. Let's just make sure. Console.log clearing execute timer, and here let's console.log else I was stopped, and let's try that again one more time. Yeah, and now continue and break. And what happens here? We are clearing the execute timer, but for some reason it keeps executing stuff after this timer has been cleared. So it could be that, let's see, yeah, we can probably console.log inside execute. Who calls execute? Yeah, it's called once here, and then we don't care about this. Probably GDB runs it when it gets a vcount, but I don't think. Oh, we did get a vcount, but then we got the break after it, right after it. So yeah, we should have stopped, but for some reason we are still running. That's interesting. Let's restart the debugger and see why we can't break. Yeah, so now we are going to continue and break, and let's see what's going on. Yeah, it's still inside execute. We can see that we cleared the execute timer, and then we somehow still got to execute, which is kind of strange. I think what's going on here is we are sending it a continue instruction even though we never stopped, and it calls execute. So I think first of all we should probably avoid this by adding if it's not stopped. Is it called stopped? Yeah, it's probably private. So maybe we'll add get executing return this dot stopped if it's not. So if it's not executing, then only then run it. So we don't want to continue. If somebody sends us a continue, we don't want to create a new set of timers. So you know, just make sure we only have sort of one copy of or one chain of execute running at a time. So now I guess if we break, then yeah, if we continue and then we break, then it should actually, yeah, it it's break. It no longer accepts my input. You can see it clearly. Execute timer never got back into execute. So this sort of worked around the bug, but the real bug is, I think when GDB connect, we should automatically break. That makes sense to me. As soon as it connects, we should automatically break. And I'm not sure if we had all of these changes. So, yeah, we can add those changes as well. Just moving those files around. Yeah, and here we can. That reminds me, I also want to export base peripheral. And also the peripheral interface, just in case a user wants to implement, some users wants to implement their own peripherals in this library without using those base classes, so they have them exported. Yes, so that's where I want to remove those new console logs. They were just for debugging, so we don't want them, but we did want this new behavior that GDB exports, that GDB doesn't stop, doesn't call execute if execute is already running. And then I want to see what did we change in GDB server, like when there is a new connection. We should probably immediately break, but we don't do it, right? I think if we are executing, then we should break. If we don't, then we shouldn't. So let's add this logic into GDB connection. So I think we are already sending GDB a response, and yeah, there was this thing where so I think there was this thing whenever GDB connected, we would also, so it was in the old version of GDB server. Yeah, so it connected, so that's the old code. Whenever we connected, yeah, we set up this on break handler, so it would do stuff whenever we break and send stuff to GDB. And I wonder what happened with that. No, we just forgot about that, so I think we should probably add this as well somewhere. So whenever there is a breakpoint, let GDB know. There is like this. Yeah, I think this should be part of GDB server actually, like handling this on break. So but it should let all the connections know that there is like this breakpoint. So I guess we should also have like a list of connections, private connections, new GDB connection, or just an array of GDB connection. And then whenever we break, if GDB is connected, so we can probably do it like that. Add connection, and connection is GDB connection. Whenever we break, we just this it can be a set probably. New set of GDB connection, and this dot connections dot add connection, read only, and this can also be read only, I guess. No, we want to let the user change this logger. Yeah, and then whenever there is like this.rb, there is a breakpoint, then we just, you know, stop, update the PC, and finally for const connection of these connections, we just connection dot on break, and those on break connections will handle on break. So basically, when we have a break from the CPU, we are doing something like that. We are just don't need this feed data as well. We probably don't need this console log as well now. We have like this logger. Maybe just this.info, it's gdb.breaks, or this.server.info, the GDB server. So whenever there is like a breakpoint, maybe we should call it on breakpoint instead of break. We are just writing. We are trying this. It may fail because the socket may have already been closed or something like that, and we don't want to fail everything. So if there was an error, and we are sending this message, let's export this value here. Const first one. This one. So yeah, this one. So if there is an error, this.gdb, and here we can, when we create a connection, we can say server.add connection and this. And if we had an error, then this.server.remove connection this. And in the server, we can add a remove connection as well. Remove connection, GDB connection. And now we officially, until now it sort of worked, but now we should officially support multiple GDB connections concurrently. Not that it's not that important, but yeah, let's put them below process GDB message. It's not that important, but I mean, wasn't a lot of work to add, so we did it. Anyways, so the last thing we need to do here is in the TCP server, if we have an error, this remove connection, just remove it, and if it's disconnected, do it as well. Okay, so now I think we should still not automatically break when GDB connect, because I don't think we are doing this. Do we? No. I don't know if we ever did it, like automatically break when GDB connects, but it does say, or it doesn't say where we are stopped. No, I think it doesn't say. So maybe maybe it does make sense not to. Yeah, now it's, you can see I'm typing. That's Visual Studio Code showing my keystrokes, but then it figures out there is no response. Yeah, I think I'm pretty happy with the way it is, where I can stop and break, but it doesn't automatically break when GDB connects. Maybe I will change it. We will change it in the future. I don't know, but at least now we have like this abstraction that whenever there is a breakpoint, I guess we haven't seen this in action because we haven't set any breakpoint. So let's just, you know, do something with the breakpoint just to see that everything works. So we have this Arduino USB, for instance. Let's run it and try to set a breakpoint and see that it still works after all those changes. So that's emulator run and load from this file. And here we probably have a bunch of breakpoints. Oh no, not the GDB. I wanted to run the code. So npm run start. And yeah, I think we don't get any output right now. What is this invalid memory address though? FFFF00. It doesn't look very good. Yeah, I wonder. Anyway, let's connect with GDB and find out, or maybe not. File.elf core critical. Yeah, it seems like it's in a break setup. Continue, and we are already past setup, so let's remove this automatic execute. And yeah, break setup, continue. Yeah, we never get into setup, or we never get into breakpoints. Where are we? I said continue. Okay, now we got into the setup. So yeah, I can see that breakpoints work. If we go to the next line, it should probably also work. Yeah, so this works. I'm still worried about, I'm worried all the time. First of all, what is this invalid memory address? Where does it come from? But then I also want to know, I break setup, and then I said continue, but it never continued. So we may still have some issue with, yeah, I think I know what the issue is. So we never called execute on the microcontroller, and I think by default stopped is false. And yeah, I think stop should just be true when we start, and this will fix this issue. So now if I just, connect without starting the microcontroller, continue and pause, yeah, I'm in somewhere. It did run. Cool. So another small issue with the DB integration, and here we can revert the changes, and finally we can commit this refactor GDB create and or move Node.js specific code to new class. GDB server is the base class for the GDB protocol implementation, and then GDB TCP server implements or uses the Node.js specific APIs, i.e. the net module. Okay, that was a big change, but now we should be able to, and we no longer this is actually a breaking change in a way, because we no longer export this GDB TCP server by default. And I think we can probably now add, we'll try that. I'm not sure if that is going to work, but we can try it. We can create a new export just for so let's call it GDB TCP server. We can call it like that, and then tell it where to this export lives. So by default you will import just import rp2040.js, import from rp20, let's create it in a file. So if you just import rp20 whatever from rp2040.js, you are getting the general code that isn't node specific. But if you are importing GDB TCP server from rp2040.js GDB TCP server, then you are getting the Node.js specific, let's make make it happy. Yeah, the Node.js specific code in that case, if you need specifically this GDB TCP server. Let's see if that works. I think that will do the trick. Why is it not allowed? I think, oh, maybe that slash, yeah. So this goes to, if we are running npm run build, then it will probably let us see how the file is called in this directory. So we have gdb tcp server.js. Yeah, so here just gdb. Let's double check the file name. Seems good. Seems good as well. And I'm not sure. I hope StackBlitz support this this syntax. It's like pretty new syntax for package.json. I hope it does. But I wonder if there is a way to specify TypeScript typings per the export. So package JSON export typings. Yeah, I think this is the the question is it's closed. Let's see if there is any suggestion here. There is no consensus. There is a workaround. The solution sounds promising. So it's like creating a yeah, but I'm not sure it doesn't. I'm not sure it applies here. Like yeah, so I'm not sure that this will actually work with TypeScript. That TypeScript will allow you to import from this, but let's do another quick search and see npm.js import gdb tcp server, npm.js or package.json exports TypeScript. Yeah, this issue sounds relevant, and it's probably a duplicate of that very long issue. Oh, it's not. So yeah, there is an open issue and it's still open. That's not a good sign. Yeah, and it seems like people are complaining. It's pretty active. It's mentioned in this worked. What worked? Yeah. Huh? What is that? Types versions. I haven't seen that. What is types versions? Package.json. Okay, not sure about that. We'll probably have to figure it out later. So right now I think this means we'll export chore export GDB TCP server separately, so that this package can also be consumed in from a browser environment. Okay, so I hope this works. Let's be optimistic and, you know, publish this as a new major version, because actually minor.10, because we made a bunch of breaking changes and refactored stuff. So let's try that and hope for the best, I guess. Yeah, I hope. And see if that works in StackBlitz. So np to publish this, and it will probably take a minute or two to just, you know, publish everything with all the changes. 0.10. And yeah, we'll test it in StackBlitz in a moment. I hope it will work and we'll just be able to import it without worrying about this net module. Yeah, I actually want to double check that we remove this import. Yeah, we no longer import net or anything that is specific to Node.js from this GDB, and we no longer import GDB from here. So why did it fail? Why did it fail? Yeah, I guess we should fix the tests. Yeah, there are a few missing imports here. So it's GDB utils. Sorry about that. Let's see if there is any other. Yeah, there is this GDB client, which goes, where is that? Did we remove it from SRC altogether? Maybe it's in test utils. So yeah, that's broken for a long time, I guess, test utils. Yeah, but anyway, let's npm test, make sure that the tests are now working. Fix broken imports. GDB. Yeah, sorry. Yeah, we make mistakes. So anyway, so let's try to publish this again, this time with hopefully tests that actually pass without broken imports in the tests. And while we are waiting for it to publish, let's go on StackBlitz. We have this project, and it will take a few more moments until we wow, this is slow for some reason, very slow. Yeah, now it's I don't know why my computer is so slow today. It isn't Friday, it should be fast. Anyway, yeah, we should probably have the version within a minute or so, and we'll test it on StackBlitz and see if it can be consumed. And now it's publishing it. If it can be easily consumed in the browser, I hope so. And if so, we don't really have time to create the entire demo, which is yeah, published. A lot of changes. Yeah, a lot of refactoring greatly. And yeah, let's publish this release. And now let's try to see if it works in StackBlitz, if we no longer get this annoying error. So updating the version, RP2040JS, they probably have some cache. So yeah, now it updated to the latest version. And let's see if it's happy and it stops complaining. And it actually, yeah, it prints a low RP2040. So now we can try to, you know, const RP2040, new RP2040, and just, you know, see that it can actually create this object. Too large to inspect, but I can see it in my browser console. We can see that it imported it successfully without complaining about net and stuff. And yeah, if we had like 30 more minutes, I would probably create this demo for the RP2040 Live, something like these demos that we had for AVR AJS. Like I would add walkway elements and then import it here, walkway elements, and then, you know, create walkway LED color red, and oh yeah, we also need this package for walkway element, lit HTML. How do we call this? RP2040 blink. And why doesn't it work? Yeah, so I would probably sit down and figure out why it doesn't work, even though it works in other projects like Word. Yeah, it doesn't really matter. We just need one with LEDs to see if we can quickly figure out why the LEDs don't show up here. Walkway LED. Yeah, I don't know. It should have worked, but I don't know. Maybe if put the import at the beginning, I don't see why it should change anything. Yeah, probably something different. I don't know why we don't get the LED here, but yeah. So if I had a time, I would figure this. Oh, I know. The TypeScript code is overriding the contents of this div. You can see here, like it's changing this element content, so that's why. So yeah, so I would just, you know, spend like 10 minutes or so integrating this Monaco code editor. Just copy the code from here basically, and then write a bunch of glue code to create the RP2040, and I think we have most of the code here already anyway. And you know what, since this is the last episode, let's do this. I will let myself to make it a few minutes longer, just so we have I wanted to have this demo for so long, so let's just do it. Let's do this copy paste, just copy the whole HTML setup from here, RP2040 LED demo, and then yeah, and then we can call it RP2040 LED demo and create, let's just create 3 of them connected to pin. We don't need both pin and label, we can just have a label, and that will determine the pin 3, 2, and 4. And why isn't it happy? Oh yeah, this one looks for the inner HTML. We don't longer need this. Yeah, and we have a few LEDs, and now we can copy the code that initializes the code editor. No, let's just copy the whole code and then make it work somehow with the RP2040. Oh, thanks Steve for the encouraging comment in the chat. Let's do this. So yeah, so we need a bunch of helper methods here, like this hex loader here. Yeah, we should probably create a package for this. So Intel hex .ts, and let's, I think we had a few fixes here, so let's just copy this from the demo code. It's even it still carries the comment that it's part of AVR.js. How do I rename the project to have a better name than this? There was a way to rename this in the past, maybe in the settings. Yeah, RP RP. Just wanted to rename it. Yeah, RP2040JS Blink. Let's make sure the title, yeah, the title could be JS Blink. Yeah, now I have this nice URL here that I will later put on the README, and we are still missing a few, so yeah, we probably don't need this runner, and we can probably get away now for now without this format time utility. So we just need to create this compile.ts, and it will just compile our code using the Wokwi build server. I think we should also tell it that this is like the board is, I'm not sure if it's Pico or iPi Pico, so let's see what Wokwi does. And when we send it a Pi Pico code, what does it send to the compilation server? I actually want to test it with the community. That was ID Pico, and so there are like two Arduino cores for the Pi Pico. One is the community one, and it's a bit faster. It doesn't include EmbeddOS, which is pretty big inside it, so the code is smaller. And let's just compile this and see what do we get in the network. What does it send? So yes, sending this build request, the options, the actual one. Yeah, Pi Pico community, that's the name of the board that we need to use. So we'll get it to use the Pi Pico compiler with the Pi Pico SDK and all of that stuff. So we got a compiler, we got, what is this? Can probably copy the CSS from here to make it a bit prettier. Yeah, let's call it style, just to stay consistent with. And then we have like blink, but this time it's 2 to 4, and then 2, 3, and 4. Just editing the demo code that loads. And yeah, I think other than that, this is standard Arduino code. And now all we need to do is just make sure that we set up the RP2040. And then when we have LEDs, not sure why it's not happy. Anyway, when we press execute, I guess when we press run, it calls compile and run, and then it, not sure why it's complaining about these LEDs. Let's try to turn it into an array. Maybe that would work. Yep. Yeah, so when we stop RP2040.stop, RP2040 equals null. So yeah, so maybe we'll just create this RP2040 object when we press compile and run. So when you press and run, we set the run attribute button to disabled, say that it's compiling, then compile the hex file based on the content of the code editor. Let's actually make it a bit bigger. If there was an error, we print it here. Otherwise, we say program is running, and we call execute program, which right now does nothing. Otherwise, we say we give an alert and say it failed. Okay, so let's implement execute program, and as you can see, it's pretty simple. It just says gets the hex, and we need to do stuff with this hex. So RP2040, new RP2040, and then let's just emulator run, load the hex file from, oh, we also need the boot ROM. Let's think, so where is this boot ROM? Let's copy it as well. So boot rom.ts, just make sure that we have this. Yeah, boot ROM, and then here we can just import it and RP2040, and then call load hex with this RP2040, and finally RP2040.execute. And I think, oh, and the most important part, connect it to the GPIO. So basically we are going to go over all of these LEDs and const pin, parse int LED get attribute. We are reading the label attribute, so that is the number that appears below the LED, and turning it into an integer, and then RT2040.gpao at pin dot add listener. We are listening for the pin state, and then state, and if state, or we can say led.value if state equals GPIO pin state dot high. So only turn the LED on if this pin is high. We don't need this function anymore. That was from the AVR code. So actually the API for the RP2040 is even simpler than the one for the AVR, for the AVR AGS library. So I learned from last time, and I made the API much simpler. If you want, you can later compare it with how this link thing works. Even though I think, yeah, that there is a simpler API for there is a simpler API now for the AVR runner as well. This is like using an older version, so it could be, this code could be simpler. Anyway, enough blubbering. Let's oh, thank you Nikadi for the comment. I'm really touched to know that you love the streams, and don't be sad, there will be new streams. I don't know yet what the format will be and how frequent and what the subject will be, but I don't think I'm done with the streams. Anyways, let's run it and see if it magically works and just goes between the LEDs, or maybe not. This is actually the first time we are having this run in the browser, like all the steps. For now, I can already say this is slow. It takes years to compile this. It's still compiling. Let's take a look at the network tab to see what's going on. Oh, it did compile. It finished compiling. And yeah, we can see the browser is sort of dead now. And I hope I saved, because otherwise I would be really sad, but I'm not sure I did. Let's open a new browser tab and see if I was smart enough to save my work. And yeah, at least I saved my work before before running that, or at least it's, yeah, it seems pretty saved pretty much. I'm not sure why why it killed the browser, but now I'm going to first of all, I'm going to temporarily change it to use my local build machine. That would probably be a bit faster than waiting for the build server in the cloud. And I will get rid of this one and open the DevTools, so I can at least try to see why it dies, why it doesn't work, where is it stuck. So run now. And now it should be stuck. Yeah, it's stuck, and now I can probably pause and see what it's doing. So where are we? Yeah, I don't know what's going on. Let's make the font a bit smaller. So yeah, so where is it? It's main thread paused. And what is the call stack? T, W, EA. That doesn't seem very friendly. Set state. It doesn't seem to be in my code at all. And this is also stuck. Let's do another experiment. This time instead of running it in the browser, I will still run it in the browser, and I will still use my local build server, so we don't have to wait so long for the compilation. This time I'm going to try to record a performance snapshot, and that may give me some hints about where it's stuck. So it's compiling. I think it's already like, this frame is very, very slow. Let's stop the recording and see if I can take a look and see why this is. Why did I mess up and why this is so slow? I'm at least glad I saved this this code before. Maybe we'll try running it in its own window. That will be easier to debug without all this tech blitz stuff going on as well. Yeah, browser is almost frozen. Yeah, I'm starting to think I might have to download the project. Okay, so now let's try to run this, and then it will probably get stuck, and I will get into sources and try to see where. So run, it's compiling. Yeah. And it's still compiling. Yeah, I should have changed the build server. Anyway, this is strange. Oh, this is like the one with the profile. It never finishes. Yeah, now the entire browser is frozen. Okay, so this actually isn't frozen. It's running. It's running very slow, but it's running. Interesting. So yeah, so it's not frozen, and I wonder why I don't see. I mean, it makes sense that it might be slow because we have this execute loop that takes a long time. I wonder why it makes this freeze, the StackBlitz user interface, why it makes it freeze even though it doesn't freeze here. Anyway, let's step out of this function. Yeah, we can see it sort of works. It calls execute repeatedly, and we can see execute was just called asynchronously from another execute. And I guess if we just press stop here, it will become responsive again, as it's no longer running the code, even though I'm not sure. Let's try to debug this. I think that was index.ts to see if it ever gets into this. If it ever attaches those listeners, and if it ever gets there. Why don't we get the state changes from the pins? Because I would hope this would at least blink these LEDs, but it doesn't. So yeah, so we can see it attaches to pin number 2, pin number 3, and to pin number 4. GPIO is like all those IO pins. And if we take a look at number 2, we can see it does have this listener. So Yeah, but then it never gets to this point where it actually blinks the LED. So I guess we may have missed something. Let's see if we missed something that we do have in this runner. So read a file, create, we load the boot ROM, and I think we initialize. Oh, we probably need to set PC to the address of the entry point, the bootloader. Maybe we should do that in the constructor instead of like counting on the user to remember doing that. But for now, let's just, add it to the demo here just before calling execute. And let's save, because we already know that this may freeze StackBlitz. And now let's run it and see what happens. Still compiling. The cloud build server is not very slow. Oh, thanks, Valerio. You found it. I just saw your comment. You found it before I did. So yeah, that's a good spot. And yeah, now you can see it working. And the browser, it still freezes, but I think it's not usable inside StackBlitz. So yeah, so we probably have to work about the performance a bit to make the browser a bit more responsive, but at least I will post the link to the chat. But at least we do have the first complete example that you can just run in the browser and hope it doesn't freeze for too long. So yeah, so I guess we should probably take a look at how to break execute into smaller chunks or something like that in order to make sure the browser stays responsive, but at least we have a working demo that everybody can play with. And so we achieved the goal we set for today, refactoring plus create this demo. And I will leave it as homework for myself to update the README. I will do it later, add a link to this new demo, remove this WAP. It's still work in progress, but it does even more than just running Arduino code and MicroPython. So I will go ahead and extend this README later this week. Yeah, StackBlitz isn't the best. And maybe we'll also create a standalone demo project outside of StackBlitz. As you can see, it's not very responsive. It's cool when it works, but right now it doesn't work so much. They also have bugs. It's not only me. Anyway, you have the link in the chat if you want to play with it later. And I think that's a good opportunity to thank you all for joining me for all these long sessions. I don't think anyone have ever built a simulator like that online in a live coding session. If there was somebody who did, I would love to know about it. But I think it is first building a simulator from scratch that can actually run pretty large set of programs that run on the physical RP2040 chip. And yeah, there is still a lot of work to do. But I'm really proud with what we have achieved together. So as Nakati says in the chat, catch you later. Feel free to ping me on Discord, walkway.com/Discord, if you have any requests for specific live streams or what you would like to see next. And I will probably take a break for a few weeks and then come back with something new. So until there is something new, have a great rest of the week and see you on Discord. Goodbye.